Now we're going to talk about even and odd functions, which is actually a review because we've already looked at how to check if a function has y-axis symmetry by replacing the x with a negative and seeing if it equals what we started with. That would be an even function. An odd function is one that has origin symmetry. So if you replace both the x and the y with a negative value and you get back what you started with, then you have an odd function or symmetry around the origin. So in order to determine if it's even, odd, or neither, I'll give you a little hint. Look at the powers. There's a reason these functions are named even or odd. So if your powers are even, you will want to start by checking to see if it is an even function. So for even functions, we evaluate the function at negative x and see what happens. Remember, just replace the x with a negative. Do not change the coefficients and do not change the powers. Those powers should be outside the grouping symbol. Just change the actual x itself. If we take a negative and raise it to an even power, it cancels out. It does not cancel the power on the x. Again, a negative raised to an even power will cancel the negative. It does not cancel the power on the variable. And then our plus 3 had no variable piece. This is equal to the original function, so it is even. Next we see we have an odd power, so we're going to check to see if our function is odd. So we are going to substitute negative x again. But this time we're going to look to see if that negative will factor out. So again, replacing just the x with a negative. Of course, a negative raised to an odd power will be negative, so we would have a negative x cubed minus 5. So now we're going to try factoring out that negative, because if we get a function that's exactly opposite from what we started with, then it's odd. But when we factor that negative, we have to factor it out of our 5 as well. So this is not exactly what we started with, what's in the grouping symbols. So it is neither even nor odd. And finally, we have another function with odd powers. So I'm thinking this one might be odd. So we start by substituting negative x for x. Again, that power goes on the outside. Now here, make sure you don't cancel that negative sign just yet. I want to see the substitution so that I know you understand what this function notation is asking you to do. Cubing a negative, we would still get a negative. And now here's where we're going to simplify by canceling that double subtraction. So if we factor a negative out of all terms, in the parentheses, what's left is exactly the function we started with. So what that means is it is the opposite of f of x. So we do have an odd function with origin symmetry. And here's a couple of U-try questions for you.